if we're looking at a sequence like this, the next term should probably be pretty predictable. What do you think the next term in this sequence would be?
14.
Yeah, 14, pretty easy. How are you getting from one term to the next in this sequence?
Add 3.
Add 3. Now that 3 is the difference between each term, so a lot of times we call that the common difference. Now, if you play around with these terms and write them in different ways, it can kind of lead you to an expression for the general term of this sequence, and then from there, we're going to generalize it to the general term of an arithmetic sequence. So the first term is 2. The second term, well, you add 3 to that and you get 5. But let me write it as 3 times 1. The third term, you're adding 2 3s, and I'll say, oh, all right, that's 2, our first term, plus 3 times 2. And then your fourth term is 2 plus, well, 3 3s. And your fifth term is 2 plus 4 3s. So you're just counting up how many 3s you add after you start out with that first term. In this case, it's 4. So what would that look like in general? How would I write the general or the nth term of this sequence? Well, they all start at the same place, right? All starts with a 3, or excuse me, a 2. So that 2 should be there. What else is common to all of these? There's a 3 that's part of it. Good. So 3 that's part of it. And then what you need to do to try and figure out what the general term is, you start looking at this and figuring out a pattern. A sub 2 was 2 plus 3 times 1. And then a sub 3, put a 2 here. A sub 4 puts a 3 here. A sub 5 puts a 4 there. So what's the nth term going to look like? If I wanted to write a sub n, what should that look like? Anything? Well, what should still be here? Probably the 2 should still be there, right? And maybe the 3 should still be there. And take a look at the pattern here. 5, 4, 4, 3, 3, 2. N
minus 1.
N minus 1. Thank you. N minus 1. So beautiful. That's the general term of this arithmetic sequence. I keep on calling it an arithmetic sequence. That's what it is. Arithmetic sequence is something that you get when the terms differ from each other by a constant amount, or that value we call D, which is your common difference. So let's write down kind of a little definition for an arithmetic sequence. So an arithmetic sequence has the form a sub n equals a sub 1 plus n minus 1 times d, where d is our common difference. What's a sub 1 for us in this? What's a sub 1?
5.
In general terms, not necessarily specific to a specific problem, but what is a sub 1? It's Hattie?
Be the first term in the sequence.
Yeah, it's just the first term in the sequence. That's all it is. It's the first term in the sequence. Nice. So let's take a look at a few examples along these lines, and for that, let me jump over to this right here. So we've got, for example A, they give us a sub n is 4 plus 2 times n minus 1, and all they're asking you for is the first 5 terms of this sequence. So I kind of like the way they write this. There's other ways you can write it, but the nice thing is that in looking at this, you can tell a lot about this. First of all, a sub 1 is going to be 4. If you put in a 1 here, 4 plus 2 times 1 minus 1 is 4 plus 0, or 4. A sub 2, 4 plus 2 times 2 minus 1. What's that going to give me?
6.
6. And I think after a while, maybe after this one in particular, you should be able to spot the pattern well enough that you don't necessarily need to go back to the formula to figure out what each of the next two are. You got 4, 6, 8. It's probably going to be pretty clear at this point what the next two values are. Come on, make me look good.
12, 10.
Yeah, there we go. 10 and 12. Nice. And that's it. All they asked for was the first 5 terms of this sequence. So nice. And when you're adding to get from one term to the next, and it could be adding a negative number, that's okay. As long as you're adding a number consistently to get from one term to the next, that's an arithmetic sequence. So nice. Bless you. Let's try some more. So let me flip over to example B. This is find the nth term of an arithmetic sequence with the given first term A. Now, just a heads up, a lot of times the WebAssign and the book, they'll write A, whereas I'll be a little more user-friendly. I'll write A sub 1, but they're not going to be quite as user-friendly. So for example B, we've got A sub 1 is negative 4, and D is 3. We want to find the general term and the 10th term. So, okay. Now the general term is going to be A sub n is A sub 1 plus n minus 1 times D. In our case, that's going to look like this. A sub n equals negative 4 plus n minus 1 times 3. Nice. They also ask you for A sub 10. So this is going to be negative 4 plus 10 minus 1 times 3. That turns into 9 times 3, which is 27. Negative 4 plus 27 gives me 23. Nice. Now, just an FYI, you could write the general form a slightly different way. If I distribute the 3, I'll get a 3n. I'll have a negative 4 and a negative 3. Well, negative 4 plus negative 3 be negative 7. So you could write it like that. I don't like it like this too much, mostly because this way I can take a look and I know exactly what the first term is. It's negative 4. Here, if I want to figure out the first term, I got to put in n equals 1 and then do the operation on the right-hand side. It's not that bad. Nothing really wrong with it. I just prefer this one. I'm not going to make you write one versus the other, but I do think this one's more convenient. Let's take a look at example C. So we got a slightly different looking general expression here. So example C, A sub n is 1 over 1 plus 5n. And I want to determine if this is an arithmetic sequence. Okay, let's write out the first 5 terms, which they tell us to do anyways, and then kind of circle back and try and decide if this is an arithmetic sequence. So I want A sub 1. So that's going to be 1 over 1 plus 5, which is 1 over 6. Let's spread it around. Rebecca, what do you think a sub 2 is going to be? 1 over what? If I put in a 2 here, 2 times 5 plus 1, 11. Good. Julian, a sub 3.
16.
16. Nice. Ella, a sub 4. And then Jason will be a sub 5. A sub 4.
I don't know, I'm still trying to piece
Well,
it
here, let me help you out. Let's put in a 4 here. If I put in a 4, what's 1 plus 5 times 4?
Oh, 21.
Yeah, 21.
Okay.
And last but not least, Jason?
1 over 26.
Nice, 1 over 26. The big question is this an arithmetic sequence? Now, in the first one, it's pretty easy to see that you're adding 2 to get from one term to the next. So your common difference is 2. And 2 again. D equals 2. And D equals 2. So that difference is consistent throughout your sequences. Are you getting the same thing here? Do you have a common difference? What do you think? This one's a little easy to get tricked by, because a lot of people look at the denominators and go, okay, yeah, 6 to 11 to 16 to 21, yeah, the common difference looks like 5, right? But really what you've got to look at is the term as a whole. You got to look at that whole thing, and then compare it to this whole thing, and then compare it to this whole thing, and so on. So let's not strain the brain too much. We pay $100 for these calculators, or at least you borrow one for me, and somebody paid $100 for it. So let's take a look. Let's take a look at 1 divided by 11 and subtract 1 divided by 6. Now I don't know what that decimal is. I'm guessing it's like 5 over 66 or something like that. So I'll just hit the math key. All right, there you go. So it's 5 over 66. That's the difference between those first terms. Actually, negative 5 over 56. Negative 5 over 66. D equals negative 5 over 66. Do I get the same thing between these two? Let's find out. So this time I want to do 1 divided by 16 minus 1 divided by 11. And that doesn't look like the same thing.
Nope.
So this time I get D equals negative 5 over 1700, or not 7, 176. Okay, so the difference isn't consistent from one term to the next. So this is not an arithmetic sequence. It would have to be the same difference, and you don't have to go any farther. Even if they were the same difference after this, it's still not an arithmetic sequence. Nice. Nice. Let's keep going. Example D. It says determine the common difference, the 5th term and the nth term and the 100th term. All right, so there's a lot to determine here. Let me start by writing down this sequence. So this is example D. 9, 13, 17, 21, etc. So I want to know what D is. I need to know what A sub n is. I need to know what A sub 100 is, and A sub 5. Now I suppose if all I needed to know was a sub 5, then I wouldn't necessarily need to go through a whole lot. Can anyone tell me what a sub 5 is, just by looking at this?
25.
Yeah, 25. Nice. But we got to do a little bit more on this, so let's figure it out. Let's see. Let's start with the common difference. What's d in each of these? 4. And d equals 4 again. So, nice. It's going to be a difference of 4. So there's our d. It's 4. A sub 5 is 25. We now know enough to fill in for a sub n. A sub n, what's that general formula again for the general term of an arithmetic sequence?
A1.
A sub 1 plus n minus 1
Minus 1D.
times d. Thank you. So a sub 1 plus n minus 1 times d. Well, we know these things. Noah, what's a sub 1?
9.
9 plus n minus 1 times d, which is 4. So, cool. Got that one. And last but not least, I need to find a sub 100. So a sub 100 is going to be n 9 plus 100 minus 1 times 4. Personally, if I was doing this, I would just do the 4 times 100, which is 400, minus 4 times 1, which is 4. So 400 minus 4 is 396. Plus 9, 405. There you go. Awesome. And that's it. You're done with that one. Pretty nice. Pretty nice. Don't worry, I'm going to get you to the part where you're going to do some thinking pretty soon.
Wait for the equation. Do we have to have d behind parentheses, or can we have it out in front?
You can have it in front or behind. Doesn't matter. Doesn't matter. Yeah. I might not even be consistent myself in writing it one place or the other. But multiplication is commutative. 99 times 4 is the same thing as 4 times 99. Right? Doesn't matter what order you multiply. So, good question. All right, let's take a look at example E. And depending on you, you could do this a couple different ways. So maybe I'll show both. It says, find the indicated terms of the arithmetic sequence with a given description. The 50th term is 1,043. The common difference is 7. Find the first and second terms. So, wow. Let's take a look at what we know. We know a sub 50 equals 1,043. And d is 7. That's all I got. Well, that's kind of thin, but it's actually enough to determine a sub 2 and a sub n. So let's see if we can't figure those out. Well, I know what d is, and I know what a sub 50 is. How can I use those things to help me out?
You can add 7. So you can find the 51st term.
Well, I could find the 51st term,
And the time before it.
and the term before it, and the term before that. But I don't want to sit here and subtract 7 on my calculator.
7 by 49 is subtracted from a sub 50.
Ooh, that's spot on. Let me show you what Jacqueline's describing here. We know a sub n has to be a sub 1 plus n minus 1 times 7, right? And in particular, a sub 50 is going to be 1043, but it's also going to be a sub 1 plus 50 minus 1 times 7. So we got a 50 here, a 50 there. Basically, 1043 equals a sub 1 plus 49 times 7. Now, I was never very good at math, so you can help verify this, but I believe that's 343. So what's a sub 1?
700.
Yeah, 700 is a sub 1. Yay. Nice. But let's look back at the question. The question wanted to know what's a sub 2?
Just add 7.
Yeah, just add 7, right? A sub 2 would be 700 plus 7, which is 707. Nice. So that's your final answer. A sub 2. All right. All right. Let's keep going. Let's keep going. Let's make it even harder. Example F. Find the indicated terms of arithmetic sequence given a description. The 12th term is 109, and the 8th term is 141. So let's write those down. So we got example F. A sub 8 is 141. A sub 12 is 109. That does kind of tell me something about D. The value of D has to be a little bit different than what we've seen so far. Yes?
It's negative.
Yes, perfect. It's negative. Because notice as you add more and more, you're getting a lower number. So D has to be negative. So you got to keep that in mind. Now the question is, how are you going to find D? Or a sub 1 for that matter. There's a couple ways you can do it. And there's a couple students in my morning class that came up with some really clever ways that I hadn't thought of myself before. So, Hattie?
I was thinking you could subtract 141 from 109, which would be negative 32. The difference between the a sub 8 and a sub 12 would be 4.
So that has to be 4 times the difference, right? It has to be 4 times D. Perfect. Yeah. So that means negative 8 equals D. Great. That's a great start. The only thing left we need is a sub 1. Remember our formula is a sub n is a sub 1 plus n minus 1 times D. And if I haven't already really mentioned it, I strongly suggest that you have this formula memorized. Let's see, does this one look better? No, it doesn't. Write that down in your notes someplace in a special spot so that you can refer back to it. There's going to be like 3 or 4 more formulas that you're going to get today that you're going to need to memorize. And then we'll get into a couple more on Wednesday. So keep this in a special spot in your notes where you've got them all together. You say, all right, chapter 12, here's the formulas I need. All right, so I know D now. So I can rewrite this as a sub n equals a sub 1 plus n minus 1 times negative 8. Okay, not so bad. I still need to figure out what a sub 1 is. How am I going to do that? There's a couple ways you can do that. Sean, any suggestions?
We could do something similar like we did last problem. Plug in, let's say 141 equals a sub 1 times 8 minus 1 times -8.
Perfect. Keep in mind that this is really the 8th term. So if I plug in an 8 here into this formula, that's really 7 times -8 plus a sub 1 equals 141. So let's see, this could be 141 equals a sub 1 minus 56, because it's 7 times -8. If I add 58 or 56 to both sides, I'll end up with a sub 1 equals 197. Awful sub 1. There we go. A sub 1 is 197. Overall, the general term is a sub n equals 197 plus n minus 1 times -8. Now I can get anything I need. I can get a sub 1000, I can get a sub 1964, get anything I need. And what are the problem asking specific? Find the first term and the nth term. Well, we did that. The first term is 197, the nth term is this right here. So, yay. Good for us. Now, just as kind of a brief aside, there's a different way you can get at that. So as an alternative to that, you could say plug in a sub 8 into your general equation, and you would get this, a sub 1 plus 7 times d. And then you can plug in a sub 12 and do likewise, you'll get a sub 1 plus 11 times d. That gives you two equations. You can solve those two equations any way you want. By this point in the course, you've got Cramer's rule, inverse matrices, Gaussian elimination, graphing, substitution, elimination. Yeah. So that's like 6 ways off the top of my head that you can solve this. There's a lot of ways you can solve this. So it's a different way to solve it. And my only point here is that there's a lot of ways you can solve problems in math. It doesn't have to be exactly like what I put in the answer key. So, nice. Let me take a brief aside and talk to you about a mathematician by the name of Carl Friedrich Gauss. And here's a little picture of Gauss, German mathematician and physicist. Gauss is listed at the pinnacle of mathematical achievement along with Newton and Archimedes. So considering that humanity has studied math for thousands of years, to be ranked amongst the top 3 is pretty awesome. Well, one of the stories about Gauss goes like this. When he was 10 years old, he was in class in Germany, and back then they didn't have paper and pencil like they do now. They had chalk slates. And his teacher got pissed at his class. He said, all right, I've had it with you guys. Add up the first 100 numbers. And back then, you know, he just took his little chalk slate and thought about it and wrote down one number. And that one number was the right answer. Can anyone here figure out what that one number would be? I see a lot of you wanting to go, you know, wailing away on your calculator. That would take a while. It'd be kind of unfun. Here's my guess as to what little Carl Friedrich Gauss did. He rewrote that series backwards. Now, if you do that and you add these together, what's going to happen? Well, let's see. If you add s plus s, you'll get 2s. But what about if I add numbers here? Well, that's easy. I get 101. And what about the next pair? Oh, I get 101 again. And then 101 again. And 101 again. All the way across, right? Now, if you had to add this up, it'd certainly be easier than adding this up. And I hope that you would take advantage of what you know. You're not going to add up 101 a bunch of times in your calculator. What's the faster way to do that? Multiply. So if you multiply, oh, okay, that's not so bad. But keep in mind, that's twice what we want. How do you get S by itself? Divide by 2. You divide by 2, and you arrive at the answer. Wow, 5,050. So pretty good. I mean, not so bad once you see it. But remember, this is a 10-year-old kid who did it on the fly. Just like, okay, I got this. And he was the only student in his whole classroom that got that problem right. So pretty cool. What does that have to do with us? We're going to sum up arithmetic sequences. And it's going to have one of two forms. The sum of the first n terms of an arithmetic sequence is going to be given in one of two forms. It just depends on, what you know. So first of all, I'm going to call it S sub n. S sub n is going to be n over 2 times a sub 1 plus a sub n. Or another possibility is, again, n over 2. This time times 2 times a sub 1 plus n minus 1 times d. All right, so two different formulas. Why would I want to use one versus the other? Well, good question. For the first one, you can use this when you know the first and last term. And the number of terms, which is your number of terms. For the second one, all you need to know is the first term and d. Need to know a sub 1 and d. I guess I should put and n. But you don't need to know the last term for this one. So if you don't have the last term, not a big deal. You do need to know n in both cases. N is how many terms you're summing up. So you've got two different formulas. So that list of formulas that you started with when you wrote down the general term of an arithmetic sequence, I would add this to that list. Because these are two more formulas that you're going to need to know to do your homework and to be successful on a test a week from today. All right. Let me give you an example. I'm going to kind of give you one off the top of my head here. Example G. And here we're going to review our summation notation. I want you to find this sum. I equals 1 to 23. And let's do -5 plus 4 times I. So first of all, let's review that notation and see what it means, see what we're adding up. So for instance, at I equals 1, if I put in a 1 here, it's going to be -5 plus 4 times 1. So it's going to be -1. What about at I equal 2? -5 plus 4 times 2, well, that's 8 plus -5 is 3. What about at I equal 3? What do I need there? What am I gonna put there? There we go, 7. And so on. What's the last term in this series? So when I equals 23, what am I gonna get for this term here? What's the last one I'm gonna be summing up?
87.
87. Thank you. So if I want the sum of the first 23 terms here, I'd call that S sub 23. And I could calculate that as 23 over 2 times a couple things. Well, 3 times a sub 1 and a sub 23. A sub 1 plus a sub 23, which in our case, 23 over 2 times negative 1 plus 87. And take out your calculator and do this. I think you're going to get 989. And that's it. Nice. Now, we actually calculated this term here. We didn't need to. What you do need to do is you do need to confirm what kind of a sequence we're looking at. What kind of a sequence am I looking at here?
Plus 4.
You're adding 4 to get from one term to the next. So that makes it an arithmetic sequence. Nice. So if it's an arithmetic sequence, then okay. It's an arithmetic sequence. Then I can use either one of these two formulas. So let me show you what it's like to use this other formula. So it would be S sub 23 equals 23 over 2. And with this formula, I don't need to know a sub n. In fact, what you do is you take and replace a sub n by the general form of an arithmetic sequence, combine like terms, you get this expression. So it's nothing too huge. It's going to be 2 times negative 1 plus 23 minus 1 times 4, which is going to end up being the same thing, 989. You know, not so bad. It's kind of up to you. Do you want to take the time to calculate this term and then use this form of the sequence or this form of the sum? Or skip it and just do a little bit of extra arithmetic here. This, when you evaluate it, should give you 86, which it will. All right. Yeah, it does. It does. All right, so there's, we'll call that example G. You get the same thing either way. Nice, they match. What I found over the years, though, is this number isn't big enough. Why? Because without knowing these formulas, it's pretty easy to go negative 1 plus 3 plus 7. It's easy to list those out. You can easily do this problem without writing down and knowing these two formulas. So what I've found over the years is I got to make this number really, really big in order so that people don't sit there on their calculator and keep on adding up numbers. At first I thought the number should be in, dozens, and then it became hundreds. One time I put a number up here like 1,000, and I literally saw somebody cover up the entire back sheet of their paper with all those numbers and try and add it up. I gave them a point for perseverance. I'm like, okay, here's a point for your courage in trying to do that. But The idea here is to use these formulas. So one more look at them. If you haven't marked them down, make sure you've got them. Those are the ones you're going to need. So here's something a little bit more like a problem that you could see on the exam. So find the sum from, well, let's do J. It doesn't really matter what you use for your index of summation. J equals 1 to 1974. This time I'll do 131 plus, I don't know, we'll do 3 times J. So you've got 2 different formulas you can use. But probably the first thing you should do is maybe write out the first few terms. J equal 1, J equal 2, J equal 3. And just make sure that this is an arithmetic sequence. Rebecca?
What's the number on that?
1974. Thank you. All right. So if J equals 1, what number do I have here? Put in a 1 for J. What do we get? 134. J equals 2, 137, and 140, and on and on and on. And you got a lot of these. Now the question is, do you want to calculate what J at 1974 is? Or do you just want to use the other version of that formula? There's 2 versions of this formula you can use. Here, as long as I've verified that this is not an arithmetic or that this is an arithmetic sequence, then I'm golden. I can just use that version of the formula. And it's true. D equals 3 and D equals 3. So it's an arithmetic sequence. All right, I don't feel like putting in 1974, so I'll do it this way. S of 1974, that is the sum of those first 1,974 terms, is going to be 1974 divided by 2 times 2 times 134 plus 1974 minus 1 times 3. Now, while you're cranking out that number, let me tell you a number that you can't get. I had somebody give me a number that was somewhere around 3053, 289.5. Why can't it be that number? Why can't you get a number like that? Hey?
You can only add and subtract integers.
Yeah, you're adding up a bunch of integers, a bunch of whole numbers. How on earth are you going to get an answer that has a decimal? You can't. So if that happens, and it's very easy to happen, you type something wrong into your calculator, whoops, okay. But if you get a number like that, you should be saying, it looks wrong. You're going to get a lot more partial credit from me if you don't give me a number like this. Because a number like this should be screaming out that, all right, there's a problem. So the actual real number was what? 6 million something, right? 6,106,000? 500 what?
569.
Beautiful. Beautiful. All right. How are we looking on that one? You okay with that one? All right, there's one last one that we're gonna look at, we'll call it example I, because I've already used a couple other letters here, so call this one example I. Example I. And this one's going to look like this: 4 plus 9 plus 14 plus da 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 plus 514. And again, I probably expect somewhat bigger numbers on an exam. I mean, I'm not going to take your calculators away, but you know, I would expect bigger numbers. Because people can reverse engineer some of this a little too easy. Now, if you check this, then what can you tell me about this sequence?
Plus 5.
D equals 5 in both cases. So, Julian, what kind of a sequence is this?
Arithmetic.
Good. So it's an arithmetic sequence. That means I can use S sub n equals n over 2 times a sub 1 plus a sub n, or S sub n equals n over 2 times a sub 1 plus n minus 1 times d. Which one of those do I want to use in this particular case?
The first one?
The second one.
You're going to run into a problem either way. I mean, I know what a sub n is, or a sub 1 is, right? That's 4, so I'm good there. I know what d is, so I'm good here. I know what the last term is, that's 514, but there's one thing that I don't know.
Oh, what it actually is.
Which variable am I missing here?
A of n.
Close.
Or D, N.
N, yeah. Problem is, we don't know what n is. So, how are we going to figure out what n is?
Go back to the original arithmetic equation.
You mean a sub n equals a sub 1 plus n minus 1 times d? What can I fill in there? Noah? Help me out.
A sub 1 is 4.
Good?
D is 5.
Nice. All right. That's good. But it still hasn't quite told me what n is.
I have 514 for A of n.
514 equals 4 plus n minus 1 times 5. And now I can solve for n. Well done, sir. If you subtract 4, you get 510 equals n minus 1 times 5. And if you go on TikTok, the pro tip they'll give you on TikTok is not to distribute and then add 5, etc. The pro tip would be just to divide both sides by 5 right here and get 102 equals n minus 1. And then what? Add 1. 103 equals n. So 514 is the 103rd term in this sequence. Now, you can use either of these. Doesn't really matter. I mean, all things being equal, I think this one looks easier. So if I want to find that sum, it's going to be S sub 103 equals 103 divided by 2 times 4 plus 514. Yeah, 514. And that turns out to be like 26,677. Beautiful. The big thing that we had to do here is we had to figure out what n was. That was the big problem that we ran into with finding the summation. So, nice. Okay. Comments or thoughts on problem number I here? All right, I think that should do it for section 12.2. Good luck with this.